Program number 1. In this program, we are tasked to make a musical jukebox. The list of songs will be listed in a serial monitor, and we can control which song to play using the keypad. The list of songs are number 1, Celos, number 2, For Elise, number 3, Ang Ganda Mo, number 4, Mario Theme Song, number 5, Coffin Dance Meme Song, and number 6, Never Gonna Give You Up. The things we need are one Arduino Uno R3, one breadboard, one 4x4 keypad, one piezo buzzer, two red LED, two green LED, four 220 ohms resistor, and some jumping wires. We begin by putting the piezo buzzer and LEDs in red, green order. Connect the 4x4 keypad to the Arduino pins. Connect the row pins 1 to 4 to Arduino pins 2 to 5. Connect the column pins 5 to 8 to Arduino pins 6 to 9. Connect the piezo buzzer's positive leg to the negative terminal. Then connect the negative leg to the Arduino pin 10. Connect the LED's positive leg to Arduino pins A1 to A4 using a 220 ohms resistor. Then connect the negative leg to the negative terminal. The keypad library is used to set up the matrix keypad. The keys in their respective rows and columns are defined. The LED pins are set as output. The LEDs will be used to create a visual pattern while a song plays. The buzzer is used to play musical notes defined with specific frequencies. Each melody, example, per Elise, is an array of notes and durations. Each song has specific function, example, play for Elise that calls play melody with a song's note and duration. Run light pattern function cycles through each LEDs, turning one LED on at a time. The program constantly checks if the key pressed on the keypad. When a key pressed, it prints the key, plays the corresponding song, and shows the LED pattern. After the song finishes, it resets the LED and prints the song menu again.
Program number 3. The hexadecimal calculator is designed to perform key mathematical operations on hexadecimal numbers, including addition, subtraction, multiplication, and division. The calculator allows users to input mathematical expressions via a keypad, with the expression displayed in real time on the serial monitor screen. Upon performing the calculation, the result of the expression is also shown on the serial monitor screen, providing an intuitive and efficient way to handle hexadecimal arithmetic. The components for this program are Arduino Uno R3 adapter, one 4x4 keypad, and connecting or jumper wires. For the procedure, simply connect row 1 to 4 of the keypad to digital pins 2 to 5 of the Arduino and connect column 1 to 4 of the keypad to the digital pin 6 to 9 of the Arduino. The program begins by including the keypad library and setting up necessary variables and arrays to manage user input and operator selection. The keypad configuration specifies a 4x4 matrix of buttons, with rows connected to Arduino digital pins 2 to 5 and columns connected to pin 6 to 9. The setup function initializes the serial communication and displays a welcome message. The loop function continuously checks for key presses on the keypad, and depending on the current state or entering digits, selecting an operator, or calculating the result, it calls appropriate functions to handle each stage. The digits function processes numeric and special key inputs, allowing users to backspace, confirm input, or continue typing digits. When the user confirms input, it prompts for an operator. The operate function appends the selected operator to the input string and updates the state accordingly. When both digits and an operator are entered, the state function ensures the program is ready for the next stage. The index operator function parses the input string to identify the position of the operator and separates the operands. The, the perform function converts each hexadecimal digit to its integer value and computes the total in decimal form. Finally, based on the selected operator, the digits function performs the corresponding arithmetic operation and outputs the result in hexadecimal format on the serial monitor. The program then resets the state to allow for a new calculation.
In this problem, we are challenged to create our own application of keypad along with buzzer and LED. This challenge is to create a lock system where it prompts the user to enter a password 3 times and will disable the keypad once it reaches the maximum tries. Things we needed. Here are the following components and materials we needed for this challenge. So, una R3, 4x4 keypad, 5 220 ohms resistor, 1 piezo buzzer, and 5 red LEDs. Prepare the 4x4 keypad. Row 1 to 4 will be connecting through pins to 5, while the columns 1 to 4 will be connecting pins 6 to 9. Furthermore, the pin 10 will be dedicated for the buzzer, and A0 to A4 connects the corresponding LEDs. Lastly, the ground pins dedicated to grounds to complete the circuit flow. This code is for an Arduino-based keypad security system. It initializes a 4x4 keypad and maps it to digital pins 2 through 9, while LED pins are assigned to analog pins A0 through A4, and a buzzer is connected to digital pin 10. The program captures keypad input, comparing it to a predefined password 05112D. If the correct password is entered, it plays a sequence of tones and lights up LEDs in ascending order. If the password is incorrect, it plays a different sequence in descending order and increments an attempt counter. After 3 failed attempts, the system locks and displays a maximum try exceeded message. Each key press is accompanied by a short beep from the buzzer. The system resets its input after each 5 character entry attempt, ensuring readiness for the next password in.